Welcome to section 3, Hadoop cluster installation. In this section, we will take a look at planning Hadoop services placement, planning Zookeeper placement, planning HDFS service placement, and also planning Yarn and Spark placement. Welcome to our session on planning Hadoop services placement. In this video, we will look at how we will place various Hadoop services across the cluster. So we will be covering some of the services, and we will look at how we can place them across different racks or different switches in terms of high availability, as well as how we can make sure there's an equal distribution of load across the cluster. We will also be looking at planning based on IO and CPU contention. For example, some services might be IO bound and some services might be CPU bound. Spreading out of masters, we'll look at we should not be placing masters on the same rack. Then we will also install a multi-node cluster, summarize, and in the next section we will look at Zookeeper placement. So services overview. So if we look at a very simplified ecosystem of Hadoop, we might have, let's say, a file system which is HDFS. I may have a tool which is a Flume, which is for pulling unstructured or semi-structured data, or I can have Scoop, which is for pulling structured data. On top of that, I can have MapReduce, I can have HBase, I can have a data warehousing solution like Hive, I can have data analysis with Pig-Latin, or I can have a very complex setup like this. I can have various input sources, maybe data coming from geolocation, unstructured data, server logs, clickstream, or I can have a layer where I'm processing multiple things. For example, I may have a connector for Oracle, SAP, HANA, or Teradata. And on the other side, I might have applications which are fetching data, maybe in a simple Excel sheet, or I might be doing a BI reporting using Tableau or Platfora or Datamere. So the environment could be very complex. So there is no golden rule of saying, okay, all these services can go in these configurations, but yes, there are certain rules which we need to follow. So in a simplified way, there are certain key points which we should be aware of. So we should be separating out services based on IO, network, and CPU contention. For example, let's say I have a name node which is bound on memory and also the network whenever it's doing checkpointing from the other node. So I should not be having, let's say, something like a Zookeeper on that system, because Zookeeper is very sensitive and it might time out. On the other hand, I should not be sharing, let's say, Kafka nodes on a system which is very high in IO, because Kafka itself needs a very reliable IO to the disk to store its data. So we have to plan for failures by spreading master nodes across racks, switches, and routers. So what does it mean? I should not be having two masters, let's say two name nodes, within the same rack. Why? Because if the rack fails, I will have an outage. So I should spread it out evenly. One master maybe in rack 1, another name node master in rack 2. If possible, have a dedicated network for Hadoop traffic with an MTU set to 9000, right? We called it a jumbo frame. So obviously when we enable jumbo frame, all the devices in between, whether router switches, must support it. Allow access only to the edge nodes to the end user, and they should not be able to connect to, let's say, master or data nodes or any other node in the cluster. They can have REST API or Web UI interface access. Another important thing is to have management nodes in the cluster. It is similar to a jump host, which could be PDSH or a parallel shell or a clutch, using which you can connect to different nodes in the cluster and control various services. Or from a cluster point of view, Hadoop cluster point of view, it can be Ambari as well. Good to have a central configuration management using tools like Puppet, Chef, so that it's easy to manage the configuration across the cluster. Another very important point is have a reliable DNS and NTP service. DNS should support reverse lookup as well, and NTP service is very important for time synchronization. So in a multi-node cluster, large cluster, non-HA, name node and resource manager on separate nodes, HBase master and Hive's server 2 nodes on dedicated nodes, and the worker nodes can be running depending upon what kind of services I install. They can run data node, node manager at the bare minimal. It can have HBase region servers, and there could be many more services as I was explaining you in the ecosystem. And the sizing of the cluster will depend upon the data size, the SLA and use cases. For example, some services might be very critical to the SLA. So obviously you have to scale the cluster accordingly for them or give them the resources accordingly. So very important thing when we talk about cluster or a multi-node cluster, how we control the services across the cluster. For example, if we have a centralized management tool, let's say Ambari, it can control the services across the cluster. Or in Apache Hadoop, if I have to do, what I can do is I can configure a passphrase-less access SSH to all the nodes, so that from one node, from a master node, I can control the services. Rather than going to each node, I can do all my operations, start, stop services from one single node. So if I have a very small cluster, 2 node, 4 node cluster, it's fine. I can do SSH to each one and do a start stop of services. But in a large cluster, let's say 2000 node cluster, it's better to have passwordless access to the cluster node so that you can restart the services. So this is an example I'm showing you of rack layout for services. So how the naming convention would be. So you will have a rack. Let's say this is your rack 0, rack 1, rack 2, and so on, right? And rack 3, rack 4. Similarly, this way you will have your rows, which will be server rows. So your naming convention would be like this. First two numbers, 00 will be representing your rack. So for example, all the servers in rack 0, they have first two bits 0. So it's kind of a naming convention. And then 0 is telling me the server position within that rack. So I can have some kind of a naming convention. I can say all the nodes who have, let's say, the first bit 0 means the second last bit 0 are master nodes, right? I can maybe configure them as name node. I can configure them as a resource manager, zookeeper, or let's say a KDC or an LDAP. So I can use some convention. For example, I'm saying C means operating system CentOS, P is a production, BD is a big data. So looking at just the node name, I can know this is a CentOS box, production box, and it is a big data project, and it is in the first server in my rack 0 and the very first server. So I can have some kind of a convention. I can say, okay, all my data nodes in my racks will start from a particular row. So I can say, let's say from row 5 onward, only I can place worker nodes, not before that. Before that, I can reserve things for master nodes or any other nodes. And here important thing I'm showing is, for example, if I have a name node here and then one on rack 01, the other name node pair will be on another rack. Similarly for RM, similarly for Zookeeper, they will be spread across different racks. HBase will also be separate. So similarly, I'm showing it for example, MySQL. The replica of MySQL will be on another node in another rack. Similarly, one MySQL server is here. So this way, we are segregating the services across different racks. So for installation of multi-node cluster, what we need, we will be following the same steps as what we did in a single node cluster. So we need a JDK 1.8 or higher. We need Linux as an OS with environment variable setup. And obviously we should have sufficient resources to run the services. So the easiest way is to clone the VM and change the IP and the host name. So we have already set up a single node Hadoop cluster. What we can do is we will just clone the VM, change the IP and the host name, and we will be ready for the multi-node cluster. So we will be looking through what are the important files which define what are the slaves of a cluster. So for example, in my case, I will be using 3 nodes. Let me show you. In my VMware or in my virtual box, I have my master, which is NN1, name node 1, DN1, DN2, DN3. So I'll be using these other 3 nodes as my worker nodes or the data nodes. To summarize, we have looked at how we will place the services and what is required for a multi-node cluster. Everything similar to what we had for a single node cluster. We will be creating multiple machines of the same config, same environment variables, same prerequisites, and then we will join them to the cluster, which we will see in our next upcoming sections. So in the next video, we will look at Zookeeper planning or placement and installation.